Alright, again we are here. We will be taking Maths 209. We are on the series Maths 209 and we'll be looking at numerical analysis. Maths 209 numerical analysis, right? Numerical analysis. And so we want to talk about the shift operators. The shift operators. The shift operators. The shift operators. We're talking about the forward difference. The forward difference and the backward difference and the backward difference. Right? Good. So now let us assume that we are on a path. We are approaching a line like this, and then we find out that here is f of x, right? So for us to move to this place, we call this place f of x plus h. We call this place f of x plus 2h. We call this place f of x plus 3h. So when you move from here to here, what is the difference between this place to this place is h. And so in numerical analysis, h is known as interval of differencing. H is known as interval of differencing. So now that we have it as interval of differencing, it means that the forward difference of f of x is where we are going to, minus where we are coming from. This looks strange, right? Where you are going to minus where you are coming from. So it means that the forward difference of f of x is f of x plus h minus f of x, shift operators. It means that the forward difference of f of x plus h is f of x plus 2h minus f of x plus h. Did you see that? It means the forward difference of f of x plus 2h is f of x plus 3h minus f of x plus 2h. That is just the definition. Is that correct? So we discover that if you are doing the forward difference of this, it will be where you are going to, f of x plus 2h, minus where you are coming from, f of x plus h. If you are doing the forward difference of f of x plus 3h, then you move again. Here will be f of x plus 4h. So it will be f of x plus 4h minus f of x plus 3h. And then we now found out that, that the forward difference has has some distinguishing properties. It has properties. What are the properties of a forward difference? Number one. A forward difference, a forward difference can obey the law of indices. In the sense that the forward difference of m, when multiplied by the forward difference of n, is equal to the forward difference of m plus n. That's the first law. Did you see that? Number two is that the forward difference has what we call a distributive property. A distributive property in the sense that the forward difference, opening the bracket of f plus or minus g, is forward difference of f plus or minus forward difference of g. So it can open bracket, expansion. It can open brackets. Do you see that? So now the third property of a forward difference is that the forward difference of a constant is equal to 0. So imagine that we are on a number line like this, and then I put here as 2, here as 2, here as 2, and I say what's the forward difference of 2? The forward difference of 2 will be 2 minus 2. Don't forget where we are going to minus where we are coming from. So 2 minus 2, which will be what? 0. So we are saying that in the number line, if you have 0, 0, 0, 0, 0, 0, 0, the forward difference will be what? 0. The forward difference of a constant C is 0. The forward difference, the forward difference of a constant C is 0. Don't forget that. Alright. So having said all of these things, let us now begin to practice some questions. Let's begin to practice some questions on it. Alright. Question number one. They said, what would be the forward difference squared of f of x? What would be the forward difference squared of f of x? Number 2, question number 2. What will be the forward difference cube of f of x? So let's solve that together. Solution. So remember that the forward difference squared of f of x can be written as forward difference multiplied by forward difference multiplied by f of x. True or false? So this means that the forward difference into the bracket of the forward difference of f of x, right? Now, what is the forward difference of f of x? Remember, we are going through this line. We are going from f of x, we are going to f of x plus h, we are going to f of x plus 2h, right? So, what is the forward difference of f of x? We say that the forward difference into the bracket of the forward difference of f of x is f of x plus h minus f of x. Did you see that? And so don't forget that in one of the properties of forward difference, we said that forward difference has the ability to open bracket, expansion. It has the ability to open bracket. So it means that we can open this bracket and say forward difference f of x plus h minus forward difference of f of x. True or false? And so this as an expression. What is the forward difference of f of x plus h? Our answer to this question is that what we have f of x plus 2h minus f of x plus h. Do you see that? Minus. Do you see that? Minus. What is the forward difference of f of x? Forward difference of where we are going to, this place, f of x plus h minus where we are coming from. So f of x plus h minus f of x itself. Did you see that? And so we will now say that we have f of x plus 2h minus 2 f of x plus h plus f of x. Did you see that? Because minus minus is 2, so minus times minus is plus. So this is the expression you have. However, we can use the approach of Pascal triangle. So let me solve this one, then we use the approach of Pascal triangles. After this. Okay. Let's solve the forward difference cubed of f of x. The forward difference cubed of f of x. What does this mean? It means that I'm saying that the forward difference multiplied by the forward difference multiplied by the forward difference of f of x, right? It means I'm saying the forward difference squared into the bracket of the forward difference of f of x, right? It means I'm saying the forward difference squared of f of x plus h minus f of x. Do you see that? I've opened this bracket. I've interpreted this by interpretation. I've interpreted this to this. So when you say forward difference of f of x, what you have is forward difference of f of x plus h minus f of x. Remember, where we are going to minus where we are coming from. So again, this means the forward difference of f of x plus h minus f of x itself. Did you see that? So this means the forward difference into the bracket of the forward difference of f of x plus h minus the forward difference of f of x itself. Right? Good. So this means the forward difference into the bracket f of x plus 2h minus f of x plus h. Now I've interpreted this. This particular person has been interpreted to this. Forward difference of f of x plus h is f of x plus 2h minus f of x plus. So now we now say minus. What is the forward difference of f of x? The forward difference of f of x is f of x plus h minus f of x itself. You see that? So let's cover this bracket. Now what do we have? We now say that what? Let's open this bracket once and for all. Let's open this bracket once and for all. I'm going to open that bracket once and for all. So we have the forward difference of f of x plus 2h minus the forward difference of f of x plus h minus the forward difference of f of x plus h, this minus the forward difference of f of x. Did you see that? So we have used this to multiply out. I told you that the properties of a forward difference is number one, the forward difference of a constant is 0. The forward difference has the power to expand, so it can open brackets. And so we say from here, we say that what this will be interpreted to f of x plus 3h minus f of x plus 2h minus f of x plus 2h. What's the forward difference of this? F of x plus 2h minus f of x plus h, right? Then we have a minus here again. What's the forward difference of f of x plus h? The forward difference of f of x plus h is f of x plus 2h minus f of x plus h, right? So that's it. That's it. Then we have minus f of x plus h minus f of x itself. So what do we have here? We have f of x plus 3h minus f of x plus 2h minus f. So this minus here, minus f of x plus 2h, minus times minus is plus f of x plus h minus, you see that, minus f of x plus 2h. Now this will be a plus, right? A plus. Minus times minus is plus. But now you can do this here. You can say minus f of x plus h minus f of x. That's minus. This will be minus 2 f of x plus h, right? Minus 2 f of x plus h. So minus 2 f of x times minus is going to give you a plus. A plus 2 f of x. Sorry. This is f of x plus 2h. This time this is plus. Sorry, this is a plus. Plus f of x plus h. Then plus minus times that, this is plus f of x plus h. Then plus f of x. So let's do that together. We have f of x plus 3h minus 2 f of x plus 2h, right? Plus f of x plus h minus, now this is f of x plus h, that's 2 f of x plus h minus f of x plus 2h plus 2 f of x plus h plus f of x. Did you see that? So we now have, so what we have right now is that we have f of x plus 3h minus, so this is 2 f of x plus h and plus 2 f of x. Okay, so it's not the same. Minus 2 f of x plus 2h, right? Now we have f of x plus h, f of x plus, that's 3 f of x plus h. So we have used this and used this. Plus 3 f of x plus h, yeah? Minus f of x plus 2h plus f of x. So this is what you will have. So you can now break it down further and say f of x plus 3h minus, so what is minus 2 minus, this is minus 3, minus 3 f of x plus 2h plus 3 f of x plus h plus f of x, plus minus plus minus. There should be a minus here. So let's confirm this answer, right? Let's confirm this answer using the binomial theorem. The binomial theorem. Let's confirm our answers using the binomial theorem. Let's confirm these answers using the binomial theorem. So let's assume that we have 4 difference squared of f of x. How do we solve this problem? By using the binomial expansion, or we say Pascal triangle slash Pascal triangle, right? So what we have now is let's build the Pascal triangle. 1 1 2. 1 plus 1 is 2. 1 1. 1 plus 2 3. 2 plus 1 3. 1 1. 1 plus 3 4 6 4 1 1. Did you see that? That is how the Pascal triangle is built. So degree of 0, degree of 1, degree of 2, degree of 3, degree of 4. Because we are on the degree of 2, we come to this place. Did you see that? We come to this place, and so we write a plus, a minus, and a plus. Plus, minus, plus. So what I'm looking at is plus 1, minus 2, and plus 1. Did you see that? So we start our labeling with f of x here. This place will be f of x. This place will be f of x plus h. This place will be f of x plus 2h. Right? So we have as a final answer f of x plus 2h minus 2 f of x plus h plus f of x. Did you see that? So let's look at if we are actually correct. Let's see if we are actually correct. By expansion, this means this, right? So we have forward difference into the bracket of, what is the forward difference of f of x? It says that what? F of x plus h minus f of x itself. And so let's open this bracket. We're going to be having the forward difference of f of x plus h minus the forward difference of f of x. Did you see that? So now study this answer. Let's write this answer here. Let's write it here. We have f of x plus 2h minus 2 f of x plus h plus f of x. Did you see that? Let's study this answer. So what is the forward difference of f of x plus h? It says f of x plus 2h, where we are going to minus where we are coming from, minus, so what is the forward difference of f of x? We have f of x plus h minus f of x itself. So we have f of x plus 2h minus 2, this and this, minus 2 f of x plus h plus f of x itself. Do you see that? So is it rhyming with what you have here? Yes. The answer is what? Yes. So we can use a binomial expansion to solve a problem on shift operators. We can use a binomial expansion to solve a problem on shift operators. So see you on the next one.